Okay, hello everyone. Thank you for being here with us today. So welcome to the small project webinar. So here I am with our experts from today. So in the order, Pablo Cueto from IDECO, Juraj Sukenik from NMS, and Juraj Beniak from Slovak University of Technology in Bratislava. As I am not sure that all the attendees are here with us, we will just wait for 1 or 2 minutes more, and then we will launch the presentation, starting with me, with the context. And yes, we will proceed to the webinar and finish with the question and answer sessions. So I will ask you kindly to wait 1 or 2 more minutes, and I will launch the presentations. So just a quick reminder for our experts and speakers from today. So we have around 15 minutes each. So I think it's a good time frame from each one of us. And then we will have roughly, if I take 5 minutes, if I'm not too long, we will have 5 to 10 minutes of questions for our attendees. So a message to our attendees: do not hesitate to write your questions in the chat box, and I will try to select them and put them in front to ask our expert about that. So okay, so as we are 4, we'll just wait 1 more minute, and then it will be okay. Yes, so okay, it's for 4:03. We will now launch the webinar. So yes, for the last one of us, thank you to be here with us today. I'm Sasaki Laila from Aerospace Valley, which is the competitiveness cluster, and I'm in charge of the project management of the small project. Today we have with us Pablo Puerto from the IDECO Institute, which is a technology center in Spain. We have also Juraj Sukenik from NMS Slovakia, which is the solution developer in the project. And Juraj Beniak from the Slovak University of Technology in Bratislava, who is professor in mechanical engineering with us. So hello to all our speakers. I will switch now to my screen and my presentation. Sorry. Okay. So about the small project. What is the small project? So, sorry, I have some issues. So the small project is a project co-funded by the EIT Manufacturing, which concerns the assembly lines for large-scale structures. Nowadays, the industrial challenge that drives the small project is that we have difficulties to have real-time measurements on the structures and detect geometrical variation really with this real-time aspect. As a consequence, the deviation that we can detect are known later, and then it can lead to delays in delivery, which is not very good for the customer. And so it brings us to the solution that we imagined. It's a solution with the title of Smart Measurement Assisted Assembly Lines. It's a smart assembly of sensors, of human-machine interface, and analysis and control devices that will enable us to have a real-time monitoring of the assembly and geometrical variations. So the objective of the small project is to shift from the current state of the art, where the assembly jigs are checked periodically, and when where the structure critical dimensions are known only afterwards, after control, and the delay is generated. And we want to shift to the real-time measurement of the smart real-time management of the jig with this smart solution. So the small project is co-funded by the IT manufacturing and the European Union, and brings it together. So hello, can you hear me? I had a problem with the connection.
Yes, right now.
Yes, it went back.
Yes.
Yes, I don't know why it cut. I don't know where it cut in the presentation.
You finished somewhere here in this slide.
Okay, so I will just continue on this slide. So we want to shift from the current state of the art, where the measurement is done and known only afterwards, and the deviation also are known afterwards, to a solution where the data's the measurements are monitored in real time, and the reaction time, so that the reaction time will be quicker. So the small project is a project co-funded by the IT manufacturing and the European Union, that brings together partners such as IDECO, which is a technical research center in Spain, NMS, who is the solution maker from Slovakia, the University of Technology in Bratislava, that will bring its expertise, especially in the field of thermal modeling, Stelia, who is our end user here in France, Stelia, which is an industrial from the aeronautics, and Aerospace Valley, the competitiveness cluster in charge of the project management. And now I will proceed to the presentation of our speakers. So we have Pablo Puerto, design and precision engineer working in IDECO. Juraj Sukenik, who is the head of the development department of NMS, and Juraj Benyak, associated professor in the Faculty of Mechanical Engineering in the Slovak Technical University of Bratislava, in Bratislava. So now I will leave the floor to Pablo, who will talk more about the comparison between the sensor technology and the advantages and drawbacks between the different solutions. So now, Pablo, I will shift the screen to you.
Okay. Let me know if you can see.
Yes, it's perfect.
No, it is okay?
Okay, Okay.
Yes. Thank you, Leila, for your nice presentation. As you say, I'm going to explain the part of IDECO, but this project, all the partners work together to find the solution for Stelia Aerospace. The index of my presentation is divided in these sections. A brief introduction, the challenge of this project, the IDECO role in this part of the project, and it is divided in two, the jig control and the process control. And I finish with a summary. Leila introduced me, but briefly I was born in Zaragoza, but I work in IDECO. I am PhD in mechanical engineer, and I have a patent using artificial vision, and I participate in several European projects as we watch, for example. About my company, IDECO is a research center, but we are close to the industry because we are part of Mondragon Corporation and Danabat Group, and as well as part of the Basque Research Technology Alliance, is an alliance from Basque Country in the north of Spain. IDECO is focused on machine tool sectors, but we are open to other sectors, like in this project with aerospace. And we have several solutions for the industry. We transfer our knowledge to the companies. And for example, I saw in this picture a solution, the ICADAS, to diagnose the machine tools, the issues with chatter and vibrations in machines. And in this video, I show you a measure system inside of the machine we develop together with Danabat, design the rest of the machine. And this is the relevance data of this sensor is it can measure on machine with level of microns of the uncertainty. About the project, Leila introduced perfectly. We, with these partners and the different aims of this project, but going deeply, we divide this project in two: the control of the own jig and the control of the process. It's the process, the different features of the process. About the first issue with the jig, there is some sources of thermal problems, like the temperature of the workshop, and also maybe sometimes the sunlight can increase the temperature of the jig, creating distortions, the formations on the jig. And about the control of the process, Stelia identified two features: the volume and the cut age. And it is different position, and we discussed with them how to control these two features. But in both cases, in the control of the jig and the control of the process, the main challenge is the huge volume of the jig. Is in meters, 6 meters the length and 4 of the height. So it is quite complicated to control this jig with the uncertainty Stelia requires. The IDECO role in this project is in the first case to carry out a thermal study, a global thermal study, and it will be an input for STUA, and also the dimensional control of this jig. And in the second part, we translate the industrial requirements from Stelia into the sensor requirements. And with the NMS, we choose the technologies, spot the correct models of these sensors, and we indicate the rest of the elements around the sensors. Wires, PLCs, and different elements around these sensors, because you have to choose all together to have a efficient solution. About the control of the jig, we divide in two, in the thermal study and in the dimensional control. In one of our first visit from IDECO visit the aerospace facilities, and we carry out several measurements using a thermal camera, a FLIR. The issue is the huge volume of the jig. We have to record dividing in different parts. This first video is about the down part of the jig, and you can see the main color is green, and it indicates it's around 20 as the ambient temperature, and the other elements in red and purple are the workers with higher temperature. So we searched in all the jig, and we didn't find any gradients, relevant gradients in the jig using this technology. So we try to go with another technology, the temperature control with contact sensors. And we place different sensors on the jig, and the jig is part with steel and other part in aluminum, and we record during more than one day. We record the temperature in these different points, and we see strong gradients when the building door was open, and also with the night the temperature goes down. So this is an important input for Slovak University of Technology in Bratislava, and it fits their models. Now the second part, the dimensional control, we use our own photogrammetric system. It's made of different elements, the cross-reference, no-coded targets, coded targets, the scale bars. It gives us the traceability of our measurements, elements to matching the images, we call igloos, and we use a commercial photo camera. This system is patented, and we receive some awards, and we use in different places and different sectors, like railways and service and goods. And we have experience in different companies, as you can see in the screen. And I have to update and place here in France, Stelia also. With photogrammetry, we compare with a very good known the laser tracker, and we place over the jig different nests, and these elements allow to transfer the measurements from photogrammetry using these targets with this dot, and the dot is in the center of the semispheric, and we can link this measurement with the SMR of laser tracker, and we can record with several tests the difference between these two technologies. Stelia works every day with laser tracker, but they see advantage of photogrammetry because it's easy to use, and we can cover with high details the jig without touching with the semisphere because we place the sticks on the jig. But Stelia saw a drawback, and we need around 30 minutes to take the photos we need to cover all the jig. Laser tracker using a lot of these reflectors, 12 in this case, they can record all the jig in seconds, because with the nest they place the nest, and with first measurements to record a nominal position, in seconds you can track this huge jig, this huge bird. So after seeing this drawback of portable photogrammetry, we are thinking, or to use photogrammetry with cameras, but stationary cameras. It's an idea we are developing, and we think maybe during this project we use in Stelia. It does not need operator, and we have it is easy to use. But we don't know how many cameras, so we are calculating the budget of this solution. But except this drawback of the time, is useful technology. And about the other part of the project, the control of the process, Stelia identify the requirements, the accuracy, the range, know the value. They need to know the value under demand. When they place the part, they would like to place a button and have the value. Very important requirement is the high density of checking points. They are thinking around 100, but depending on the budget, we will see. Around all the surface. And about the cut edge, we would like to know the age of this part, the position, respect the year. So IDECO identified several technologies, and we discard a lot of them, but at the end we choose for the volume 2, the laser analogic, and the ultrasonic also. They have the requirements Stelia identified, because both are robustness, the management is easy, the quality of signal, accuracy, all of these they satisfy. But NMS carried out some tests, and I don't want to spoil the Jura presentation. In the case of the cut edge, IDECO identified the 2D laser, and NMS add another technology, the light contrast. But as I say, Jura explain better deeply this process. In summary, we pick up the industrial requirements from Stelia. We choose the correct technologies in this different process, and we carry out the jig control measurements. So thank you.
Thank you very much, Pablo. Very nice presentation, and showing the comparison between the different technologies adapted to Stelia needs. So thank you for this outlook. And we are right on time, so thank you for that. And now we can switch to Juraj Sukenik from NMS. who will present us with a general overview of the methodology, how to develop this smart measurement solution. So starting from the sensors that Pablo already talked about and going until the human-machine interface and even beyond. So now I will leave the floor to Juraj Sukenik from NMS. I will shut my microphone. And yes, you have the upper hand, Juraj. So thank you, Pablo. Pablo, maybe you can, yes, thank you.
Okay, thank you, Leila, for introduction, and also you, Pablo, for your part. I will make some follow-ups on your presentation. I'm not sure that you are able to see my screen. Please just let me know.
I will show it. Yes.
Yes. Okay, then. So I will make just the follow-up on the information from Pablo. So basically, NMS was responsible for solution as a solution maker. I will go through just some content as an introduction. I would like to introduce in a really fast way NMS company, then myself, continue to the project methodology, NMS role in a small project, then how we test the sensors, how we set up the concept and define the concept of the product, and the final topic will be HMI. So NMS, we are a company that's mainly focused on absolute automated solution in measurement field, especially in automotive and aerospace industry. So basically, we are using products and the benefit of products Leica to automate the metrology cells and make the absolute measuring systems at customer sites. There's a lot of benefits from this technology that can happen to the customer. We changed the logo from like NMS is there still, but it was non-contact measuring systems. And right now it's new manufacturing solution because we would like to help to customers to find the solution for their needs, not just by the measurement systems, but as a whole process, just to control the process, not just through the quality, but for also the rest of the processes. So that's NMS. We are spread it mainly in Europe, but we have also subsidiaries in Brazil, Russia, and we try to spread also in different regions. So as I told you, as NMS official mission is inspiring manufacturers to accelerate productivity through in-process quality control. That was also the reason why we changed the logo. So basically that's NMS. Me, myself, I'm NMS from 2016, and I go through the project execution. Then I'm right now responsible for whole development department. So basically the team on my department developed the solution of the small projects itself. So we are sitting in Slovakia, and whole development department is right here. So as the rest of the presenters, I made a study mechanical engineering and also business economics. So small project and also NMS development department. We are working with slightly different management as in previous time. We are using agile techniques because the development process is something live. So we have to be agile. We have to adapt on the situation, mainly because at the beginning of the project, no one can give you all necessary information because a lot of really really interesting things and requirements are done just in the duration of the project. So if we find something that it's not technically possible, we have to find different way, and then the requirements slightly change. So we need to adapt on this. That's the reason why we are using Scrum project methodology for development, and that's also the case for the small project. Basically, it means that we are able to be really agile, and every 2 weeks, because we have 2 weeks sprints, we are able to give you another increment, so another functional part of the project. So we are able to develop the functionalities partially, not wait till the whole product is developed. That has a lot of benefits because we are able to test it in the meantime on the real things. So that was Scrum. So NMS role, we are, as was introduced by Leila, we are solution maker in this project. So we are the men that have to put all the bricks together to build the product. So we need to have this information that was also presented by Pablo, and that will be presented by Juraj Beňek from Slovak Technical University of Bratislava. Basically, we made some additional sensor research and validation as the first thing, because we need to know from what appliances and the sensor we can use for the product. Especially, we not focus just for this single thing, because it has to be product. So we need to think more universal way how to use the sensors in case of different materials, different environments, and so on. Then we thought about calibration, accuracy, linearity, validation, then put it together as an initial component, the sensors for whole product, put it together by another hardware as a sensor holders, special supports, calibration tools, cabinets, electrical cabinets, and definitely by controlling software which will control whole process inside of this measurement of the large scale jigs. Then it was necessary to develop mechanical and electrical components for whole product, and software development validation is one of the biggest part of the development, because today the software control everything and need to process all different information from sensors, communication cards, inputs from the operator side, so a lot of things. And at the end, we have to build HMI interface, which will display in really friendly way the information from the product, from the system to the user, because it needs to be really simple, and user needs to know every time what's happened with the jig. That's the reason why it's real-time measurement. So basically everything on NMS side is about seeking the solution for the problem that we discovered, not globally, but also partially, just to optimize the product itself. So as I told you, there was some market research for grooming the data and to be able to compare different technologies in case of sensors. The way how to make it is especially testing. So we have to develop the methodology for tests and define the requirements together with rest of the partners. Then, because we have had a COVID situation, sometimes it's really hard to travel. We need to build a test stand that will represent the same sample as the product or the jig in reality. Just try to simulate the conditions. Censored tests, so we need to perform the test. I will explain later. And then make assessment and analysis and choose the the sensors with respect of their universality, not just for special case, but also for a case that we will measure different material in different conditions. So there is a lot of requirements there. Regarding tests methodology, we need to have something like a stable conditions as the initial one. So we measure all of the sensors in the same time. This is most important because then we are able to secure the same condition for the measurement. And also important thing is that the temperature was measured and it has to be measured continuously during the test, because we can then there find some pattern how the sensors can behave also with respect to the changing temperature. Each measurement has to be measured minimally 100 times, and we'll log the values from the sensors. Between each measurement, we have to switch off and back switch on the sensors just to simulate the real conditions during the life cycle of the product, just to be able to replicate the measurements. And we made all of the measurements in our lab. So basically, you have to consider a lot of changes that can happen in real life to the sensors. So as the initial stage is just to build stable conditions, approximately 20 Celsius degree, no airflow, just artificial light. Then the first test, when you would like to make changes, you have to make just a single one. Then you are able to identify, okay, this change can cause this to the sensor. So we change the temperature, and the temperature can be changed in a slow way and also fast way. Then you can change the sunline, because this is also the reality in production halls, because you have roof windows right above the production line, and the sunlight can influence some measurements, especially non-contact ones. Also, with respect to the ecology, a lot of production halls have LED lights. That means that LED light with their wavelength can also influence some sensors. That was confirmed also by our tests. Then airflow by ambient temperature, but you can have also heated airflow because you have some kind of air conditioning inside of the production halls. So the same. We can find also some oil stains during the production or another stains that can influence optical measurements. And we definitely have to simulate some gaps because there is some uncertainty in production that can cause these and can influence the measurement. So the parameters that we have to check is accuracy, linearity, sensitivity, and ambient temperature. You can see here in the pictures some really simplified test that was able to simulate the conditions, the real one. The important thing is that the material is the same one as will be used in reality. This is a really important thing because the structure of the material and upper surface is the same and can influence the results. So we can see there different influences. On the left side is LED light. Here you can see some logs from the tests. It was really strict measurements, and there we can see also Gantt chart, the Gauss chart here for this decision. So for making decision which sensor is better for that application and or whatnot. As a summary, you can receive some table which test the sensor pass or not, and then you have to also consider some another aspects, not just accuracy, linearity, repeatability, but also in case of the product, dimensions, if it's compact enough to use it in the jigs, communication interface of the sensor, resolution, safety also, because we have also some laser sensors, and the sensors have to measure also during the time when the operators are moving inside of the jigs. then also outputs if it's digital or analog, the temperature range, the working range, maximum possible length, because we are talking about the large-scale measuring system, warm-up time, because it needs to be real time, so you don't have time to wait something like 10 minutes for warm up the sensor, response time, calibration necessity, and so on and so on. There is a lot of criteria that have to be considered. And at the end, definitely price to performance ratio. Regarding the concept definition, you can imagine here's some sensors that will measure the jig itself. Then you need to have that data acquisition model to process the data together with the data processing. And then you need to display the data somehow in a really nice way. So it needs to be universal, compact, easy to modify, definitely safe, time effective, and finally user friendly for the operators and for the users. So during the testing phase, the solution area, definitely mechanical components, because the sensor itself is not playing any role. You need to have definitely firm holders that it's possible to place somewhere. You need to have electrical components, because there is a lot of cables. We are talking about 100 of sensors, so you can imagine how many cables and wires are inside. Connection schemes has to be developed, because we have different communication interfaces from each sensors. Safety concept, definitely. Calibration concept is really necessary, because if you need to calibrate so many sensors, we developed something like, we call it zero calibration, digital calibration, that can be introduced afterwards when we finalize the product. You have to define the limits, because operator can see, okay, we have 100 sensors, but on first look, he need to know which sensors or which areas of the jig are out of the tolerances. We have that data logging, and also we need to visualize results in a really friendly way. So basically you will see it afterwards. So the visualization, how to make it? Definitely the best way is to use touchscreen. So it's really natural for people touch things. So touchscreen and really simplified accounts permission, so user can log in or don't have to. It's up to the customer. Then it has to write some part ID, because whole system needs to be traceable. If you have some parts which can be out of tolerance, at the end you need to trace it through the production line. Then display measurement results, and also HMI works for system status visualization. So here you can see just a really simplified view. We have also some possibility to use the 3D models, 3D visualizations, but it's under the NDA. But you can see here how we are able to display the values from the sensors. The green light means that the area of the jig is okay inside of the tolerances. The amber one is in the first limit field, and the red one is above the limit. So if someone is interested in what's the value there, just touch the traffic light and you can see exact values from that digital zero calibration. So where that screen, when? Immediately, because it's real time, so we collect the data from all of the sensors real time. How to display it through the touch screen, 2D, 3D. And basically that's all from my side as a development from the sensors testing, collecting data, data acquisition, processing the data, make their internal logic for the controlling system as the inputs from the operator, and at the end HMI and visualization of the results.
Yes, thank you very much, Juraj. I think the structure of your development is very clear. from the especially for the prototyping phase. It was very good to see an image of the prototype and the practical details, such as the real material used in the industrial conditions. We've also seen some support that you made with 3D printing. It's another thing that should be highlighted, that you are very reactive thanks to this kind of small details that helps you to be reactive and really close to the needs of the customer.
Yeah,
so thank you very much, Juraj.
Yeah.
Yes. And now we will proceed, as we are a little bit short on time, to the presentation of Juraj Beniak from the Slovak Technical University of Bratislava. Yes, the two presentations we've seen now, I think the attendees have some questions, so feel free to prepare them for the question and answer session that will come right after Juraj Beniak's presentation. So Juraj, I will leave the floor to you about the contribution of thermal modeling in this project.
Okay. Thank you for the word. Good afternoon, everybody. So right now, I will let you know something about the role of the Slovak University of Technology in this project. So as you see, the Slovak University of Technology in Bratislava is the best technical university in Slovakia. It is a very modern research and higher education institution. We work annually on many number of the projects which are granted from the private sector and also from the European Union. Part of this whole university is a faculty of mechanical engineering, which brings quality teaching of engineering study field here in Slovakia. During the period of our existing, the faculty has significantly strengthened its position in the Slovak teaching field. We have very good cooperation with the Slovak company, but also with the companies in the European Union and also around the world. We are doing research in the many areas of mechanical engineering. As you can see, this is the structure and the field of interest of Slovak University of Technology and the Faculty of Mechanical Engineering. We work, for example, with automation or doing the research in the automation, robotics, quality management, but also additive manufacturing, mechatronics, material science, smart mobilities, reverse engineering, and others. Me personally, I work with computer-aided systems. In this field is also the CAD system and also the simulations. And also I work with additive manufacturing and production tools. Slovak University of Technology, as a member of the SMART project, brings a little bit different approach for solving problem with precision of the large-scale structures from different point of view. As you see, the partners of this project, like IDECO and NMS, works on the application of the sensors to monitor the position accuracy of the structure on the jig. So as you could see in the previous presentations, and Slovak University of Technology works on software simulation, which have a credible described effect on the temperature on the whole structure and brings knowledges about the deformation which are caused by external factors change. Specifically, we will say about the temperature change. For this purpose, computer simulations are used to predict the behavior of the whole structure and their parts while respecting the real structure and properties of the real structure. So we have to use as much as possible to exact input data for such a simulation. In order to achieve the most accurate simulation results, it is necessary to enter the maximum amount of information into the system. And in this, we cooperate very close to the IDECO aerospace area, also to the NMS, to discuss which factors and what details are very necessary for such a thermal simulation or simulation at all. For example, there are information about the structure, how the individual parts are connected together, and what are the relationship between them, which parts are moving alone or which are completely fixed and have to be fixed in the simulation. There are also information about the material used for a manufacturing of such a structure, which is in the simulation. And if we are talking about the thermal analysis, so it is very necessary to know the coefficient of thermal expansion for such a simulation. This need to perform such an analysis is the fact that in the space or in the workshop where the monitored structure is located, there is a significant change of temperature during the year when the outside temperature change, but also during the day and night. So as you saw before, the IDECO made simulation and bring us some values to know what are the levels at which the temperature is moving and what values of the temperature change should be used for a simulation and to gathering like a proper output from such a simulation. The factors such as a opening of the large gate when they are handling with a large objects in the workshop, but also the example and also, for example, the location of the roof windows on the roof of the production hall, through which the radiation sunlight influence the structure and whole area or whole field of the production hall. The airflow in the workshop also contribute to this. All these factors have a significant effect on the simulation results and the behavior of the structure. So all of this information have to be taken in consider during the simulation. Like input parameters, we can talk about the temperature range, which we figure out with the partners through the measurement. But we also perform simulation and other temperatures ranges as required by the project partners and when it is needed. Then we can talk about the material properties, and from this it is very important thermal expansion coefficient. Then we can say about the adjusting the contact surfaces so that they respect the behavior of the real condition of the real structure. So it means that the the whole design is consists from the separate parts which are, for example, screwed together or fixed somehow together. So we have to respect such a context. Then it's very important to make a simplification of the 3D model which we had from the producer, because the very small objects or very small parts have a big influence to for a meshing, to make a mesh of such a structure. So simplification must be used for a computer simulation purpose. Otherwise, there is a very big risk that the simulation will fail, or basically not the simulation itself, but the meshing process is failing a lot. We tried on beginning to use the primary parts from our partners, but we figure out that there is so many little bit small errors, a lot of intersections, a lot of small parts which are not suitable for such a massive simulation. So we made a little bit simplified models. So what we did, we just remove a lot of small holes. We remove the washers, screws, small parts like a little small plates. But we have to care that such a simplification do not affect the final result which we expecting from the simulation. But the simplifying the design of the purpose of simulations and calculations of the various kind is common practice. Yeah, it is usually we are doing this because the hardware and software cannot be prepared for a huge simulation. So it is very important also to use the suitable mesh, so we can adjust the mesh with different parameters. Also, this meshing process affects the final result which we are expecting from the analysis. For simulation, we use the final element analysis, which is broadly used in this area. One of these possible analyses from this group is thermal analysis. There are three mechanisms of heat transfer, like conduction, convection, and radiation. But for our purpose in the thermal analysis could be used the two groups of or two models for a calculation. It is steady state thermal analysis or the transition thermal analysis. In the first steady state thermal analysis, we are interested only on the final state of the structure, with not respecting the time process when the structure is heating. For the respecting of the time, there is a transient thermal analysis. But for our purpose, we decided to use the steady state thermal analysis, which is very broadly used and is totally enough for such our purpose. So we first perform the calculation separately on the small parts. the whole structure consists from the three basic parts and from three different materials. So we tried first of all the simulation on the smaller parts. When we figure out all of the problems and all of the errors which could be in the process of the analysis, then we come to the final analysis of the whole structure. Yeah, we can see on the pictures how looks the final result from such an analysis. On one picture, you can see just the color map, which reflect the dimensional or the deformations, and on the another we can also see the deformation over here, yeah, after deformation. So we can very easy detect with different softwares which are ready for thermal analysis. We can detect the position or the deformations in the a whole structure, but we can focus also on the deformation in the separately axis, like X, Y, Z. And we can compare such outputs. What we can do is also to make read the final numbers, final deformations on the exact points, which could be, for example, defined by the NMS on the places where the sensors will be applied. So this is probably very important to know what will be the final position of monitored points where the sensors will be applied. And on the last picture, on the last slide, we can see the small animation, how looks the output from the thermal analysis. All of the data are, after the analysis, are double-checked and make two more simulation to compare the data if it is okay or not. So this is what we do in this project. Thank you for your attention.
Thank you, Juraj, for the very clear presentation and the insight of the temperature simulation and the view you offered us on the software. So yes, so thanks for all the three speakers today. I think we covered pretty much a big portion of the project and the different topics we had to deal with. And now we can proceed to the question and answer session. So for the attendees, feel free to ask some question, and we already have some very interesting one that already arose. Maybe I can ask to the speakers to activate the camera so we can see them. Yes, and the first ones are for NMS and also Pablo. We have a question dealing with the sensors. I will try to find it again. Yes. So the attendee would love to have your views and potential solutions you see that already work to zero in or reset remotely the sensors inbuilt on the jig. So I don't know if I'm clear. So I don't understand what it's meant by zero in or reset remotely. Maybe it's a solution that could be maybe it's about the zero calibration you talked about, Juraj. Maybe it's related to that, and yes, your views and potential on this kind of this sensor that could be calibrated?
Yeah, basically,
yes, remotely,
I guess.
Remotely.
Yeah, I guess it's about the digital zero calibration. Basically, it means that we will calibrate the sensor for some reference, and normally you have to. I know from my experience that normally in aerospace you have to shim everything, also the sensor in X, Y, Z direction. But all of the measurements in case of the monitoring, the jig and the part inside of the jig, it's just relative. It's not absolute measurement. So we need to just measure locally if some distances, like with dimensional sensors. So we are able to calibrate the sensors digitally by some reference. So it doesn't matter if the sensor in their measuring range, if the sensor is precisely something like a 20 microns located in X, Y, Z directions, because we are able to post-process the data and calibrate the sensor in the nominal values. And for that, we are using the calibration tools, and it's definitely possible to make it through the software, because inside of the small product, it's also the possibility of the maintenance menu and approval, and all of the trained people and the maintenance guy can make this digital zero calibration. I don't know if that's the reply on this answer, because honestly, I'm not for 100% understand maybe the question, or if it can be defined more precisely, I can give to the attenders more precise reply.
Okay. Yes, and we had also some questions. Maybe we can proceed to the second one. Yes, thank you for your reply. Yes, from your experience during the testing phase of the sensors in real case scenarios, what's your evaluation of the reliability of off-the-shelf sensors? I think it's more meant to Pablo and Juraj.
Maybe I will try to answer. Off-the-shelf sensors manufacturers, basically there is some physics behind all of the sensors, because you have different technologies. For example, for measurement, you can use laser triangulation, 1D, 2D sensors. You can use ultrasonic sensors. You can use mechanical sensors for dimensional measurements. And each kind of these technologies has some obstacles. For example, the laser sensors and the direct sunlight, because the direct sunlight has really some peaks in the wavelengths that can influence the laser light, especially the red one. So this kind of test was done because we need to use something like a universal solution for multiple applications, not just for this one, because it has to be product. And off-the-shelf sensors manufacturers, in really good brands, they are using some filtrations, for example, in laser sensors. And normally, the cheaper one doesn't use as much clever filtration, so that effects can happen there. So there are definitely some differences, but basically, most of the differences are because of physics itself and the technology.
Okay.
Yes, just to add the answer of Yura, in this case, when we choose the technologies, we speak a lot with Stelia about their experience with different technologies and in their workflow. So we add all our experience, NMS and IDECO and Stelia experience about the technologies to try to choose the best solution and also considering the drawbacks and the possible issues in the future can appear, and try to avoid them. I think NMS carry out several tests in laboratory, but they also add a battery of tests, several tests in Stelia to find all the possible issues. So with this all information, we start the installation, the final installation with experience.
Thank you for your lights on this. I will just show my screen. Yes, we have still a few questions, but I will show this this slide. If you have any further question or you want to contact the expert and the speakers, feel free to contact me through this this email you see, and also excuse me, I am doing that this way. And also there is the LinkedIn account of the project, so feel free to add the LinkedIn account and follow us, and also contact us through this media, and if you want to be put in contact with our experts. We had also very interesting questions dealing with the thermal modeling. So Juraj Beniak, it will be more for you. I will try to find them again. Yes, here. So there are two questions in one. So first, what's the what assumption in terms of temperature variation did you take in account first? And then second, are the result of thermal deformation used to correct measured data?
Yeah, we are doing this simulation because we want to apply this result to maybe to the calibration or to evaluation of the measured values. So this is the main reason why this simulation is in process. For now, we are still working on the final simulation, because the simulation is a little bit like a process. It is not that you switch on the computer and put the number inside and you have immediately the output, but we still have to put some input values which are missing right now over there. And what was the first question?
Maybe I'd like to add for this answer, this thermal modeling is really important, because most of the time customers which have large-scale jigs don't know what's the behavior of the jigs in case of the changing the temperature locally and also globally. And these thermal studies for thermal expansion can guide us where we have to place the sensors just to monitor the dimensional deviations and monitor the behavior of the jig. So this is the most important thing, how to use the thermal modeling.
Okay, thank you.
And yes, maybe one last question to conclude the webinar, as we are a little bit short on time regarding the platform. Yes, there was a question about wireless sensors, and I think it's a very clever question. So have you explored, researched the wireless sensors versus wired sensors? And maybe we can talk about the advantages and drawbacks they could have. Maybe Pablo on this topic.
Yes. Thank you, Leila. Wireless sensors is a trend. I consider it is the future, but nowadays wireless sensor have some drawbacks, like the battery. The issues with the communication. You can have interference between all of them. And also the wires. In this case, for example, to move all these wires to address the wires to the cabinet, it is an issue because the number of sensors is quite high, and it is a problem to combine with the rest of the jig. The manufacturer of sensors start to create solutions like hubs to join several sensors and try to reduce the number of number of wires. And also, but it is a trend, but nowadays, in my opinion, is not, and in this case, of course, is not the best option. To control the jig, instead, the photogrammetry is wireless, because we place the targets on the jig, and we can measure with the camera, and we don't need to touch the jig. But we have the latency of the measurement, because we take the pictures, and by Wi-Fi we send to the computer, and we process the solution, and we need time to have the picture on the computer. But maybe if we need more reliable, more fast answers, photogrammetry is not a solution. The next step on the solution is laser tracker, and they are improving the latency, the frequency, of the frame rates of these solutions. So it is a trend, but with care. We have to take care of to use wireless sensors,
Okay.
in my opinion.
Thank you very much for this clarification about the latency issues and the interferences they could have. Okay, as we are a little bit longer than expected, we will now proceed to close the webinar. So thank you, thanks for all the attendees that stood up until now. Thank you to all the speakers who shared the expertise with us. And do not hesitate to contact us through our LinkedIn or Twitter page. And so if you saw my email, so feel free to contact me also. And if we want to be put in contact with any experts you heard, I will do this. Okay, thank you very much, and have a nice evening. Goodbye.
Bye.
Bye-bye.
Bye.
Have a nice evening. Bye.